In this video, I'm going to introduce the unit circle. So we start off with a circle of radius 1 centered at the origin. So I have this picture shown here on the left. And the unit circle is of interest to us because we can use it to define sine, cosine, or tangent. Or we can use it to figure out values of sine, cosine, and tangent. Okay, so I'm going to start off by picking an arbitrary point AB on the circle. Now we have the radius from the origin to that point AB, and I'm going to define theta to be the angle from the positive x-axis to that radius. So if our point AB is in the second quadrant, then our angle theta is going to be greater than 90 degrees. Okay, now remember that we defined sine, cosine, and tangent using a right angle triangle, or a 90-degree triangle. So I can draw a perpendicular line from the point AB down to the x-axis, and it forms a 90-degree angle with the x-axis. So now we have our 90-degree triangle. So since this was a unit circle, that's telling us that the radius of the circle has length 1, which means that the hypotenuse of our triangle has length 1. Now, since this is the point AB, that's telling us that we are over a distance of A and up a distance of B. So the second coordinate, the B, is telling us that the vertical side of the triangle is length B, and the first coordinate, or the A, is telling us that the base of the triangle has length A. Okay, now remember we had our SOHCAHTOA definition of sine, cosine, and tangent. So we know that sine of theta is defined to be opposite, so the opposite side, which is at vertical, over the hypotenuse, which is the side of length 1. So here we have sine theta is opposite, which is B, over hypotenuse, which is 1. And so that's telling us that sine theta is just equal to B. Now, cosine theta is adjacent, which in this case is the base of our triangle, over hypotenuse. So we have cosine theta is A over 1, which is just A. And for tangent of theta, we know that tangent is opposite over adjacent. So we have that tangent is B over A. Now, since we just saw here that sine theta is B and cosine theta is A, saying that tangent theta is B over A is the same as saying that tangent theta is sine over cosine.
Now I'm going to show how we can use the unit circle to figure out different values of sine and cosine. So here I have a unit circle with different angles marked in. So we have 0 radians, pi over 6 radians, pi over 4 radians, and so on. And just a reminder that in calculus we tend to use radians instead of degrees. So looking at this, we know that pi over 2 radians is the same as 90 degrees, but we're going to refer to it as pi over 2 instead of 90. So just to have as a reminder on the bottom there, I have that any arbitrary point AB on the circle is cosine theta, comma, sine theta. So now I have a bunch of different cosine and sine values on the right-hand side. So if you want to pause the video for a moment and see if you can figure out what these values are, you should do that now. So starting off with cosine of 0, the angle 0 is the point 1, 0. And since cosine is the first coordinate, we have that cosine of 0 is 1. Now for pi over 2, we've now moved pi over 2 radians around the circle, which is the same as 90 degrees, so we're now up at the point 0, 1. Again, cosine is the first coordinate, so cosine of pi over 2 is 0. Now for cosine of pi, pi brings us to the point -1, 0. Cosine, being the first coordinate, gives us cosine of pi is -1. And now for the last one, we're at cosine of 3 pi over 2, so we're at the point 0, -1, and so we have 0. Now for sine, we're going to be focusing on the second coordinate. So sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, and sine of 3 pi over 2 is -1. Now, you might be wondering, what about tangent? Well, we saw before that tangent is the same as sine over cosine. So if we're interested in finding these 4 values of tangent, we know that each of them is just the same as sine divided by cosine. Okay, well for the first one, we have that sine of 0 is 0 and cosine of 0 is 1. So we have that tangent of 0 is 0 divided by 1, which is just 0. For tangent of pi over 2, we have sine of pi over 2 divided by cosine of pi over 2. and that's 1 divided by 0. However, we aren't allowed to divide by 0, so in fact, tangent of pi over 2 is undefined. Now for tangent of pi, we have sine of pi divided by cosine of pi. That's 0 divided by 1. Oops, that should be -1. And so we have that it's 0. And for our last one, we have that tangent of 3 pi over 2 is 1 divided by 0, which again is undefined.